Okay, that means this is our last session and it's the final exam review, and I will cover only chapter 10, of course, because that was the last stuff, and I will focus also on chapter 11 and mainly on the stuff that were covered after the exam 2, which means the new stuff. Okay. As we probably know, the test will be open this Thursday and will stay open until Wednesday, August 8th. That means from August 2nd to August 8th. Okay. And probably you do have an appointment on Examity, which is great. I think I saw almost everyone. That means that's good. And another short information, which I think I sent this through the weekly email. That means the final test will contain 25 multiple choice questions. Each of them is worth 8 points. And the distribution is pretty much 60% will be the old stuff, like the exam 1 and exam 2 material, and the stuff that will cover after will 40% of the questions will involve the new stuff. Right? That means it's not 50, not half of the test, but almost half of the test are the new stuff. And as always, we can't use any calculators, any notes, any electronics, any textbook during the examination. And this time we will have 120 minutes, 2 hours. I think it's plenty of time, and especially when you practice. I'm also hoping I hope you did start practicing the sample test, but please remember, I know that I'm repeating this. I did repeat multiple times, but take the sample test as a real test, which means 120 minutes, no additional like help, calculators, notes, textbook, just you and empty desk. Okay, and then the result will really show your readiness for the test. Okay? And of course, don't try to make any breaks, any bathroom breaks, any coffee breaks. Yeah, just take the test. And I think we do have lots of sample tests, and they really reflect the type of the question and the level of difficulties of the actual test. Okay, that's me. Let's just solve. I choose a few problems for you. And let's solve them. Then we will see what kind of concept we have to know and what kind of concept you can expect on the test. Okay, that's what I have. Yeah, I will have a few questions. Some of them will be multiple choice, some of them will be just without the options. Okay, that means my first question is about the sum of the infinite series, which I think is just the beginning of chapter 11. And you can probably see and you can recognize that this is geometric series, because based on the option, you may guess that if I am asking for the sum, actual sum, it must be geometric or telescoping, because that's the only infinite series that we are able to compute the sum. Okay? And the infinite series is defined as a -1 to the power of n plus 1 plus 2 to the n minus 1 over 3 to the n. That's the reason that I said geometric, because all of the n's are placed in the exponent. That's how we can recognize. The only thing that we don't like is the addition. Okay, that means addition is not really the part of the geometric formula, but we can split. That means let me start writing. I will switch off my camera, that will be easier for me. Okay, and then we remember we have to split for 2 series. That means this will be the first one, and plus the sigma notation, and 2 to the n minus 1 over 3 to the n. And then we can deal with both of them. If one of them is divergent, then the entire sum is divergent. If both of them exist as a finite number, then we can add together and have the final answer. Okay, that means this is definitely the geometric one. we can see that the common ratio is a number that is taken to the power of n, which is -1 on the top and 3 in the denominator, -1/3. And this is the absolute value of it is less than 1, then this is definitely convergent. If it's convergent, I can compute a sum. Actually, I need a first term because the sum is A1 minus R. And A is just a quantity of this formula defined at n equals to 1. That means if I substitute instead of n1, I will have -1 to the 2, which is 1, and 3 to the power of 1, 1/3. Okay, that means let's compute the sum. 1/3, 1 minus -1/3. And this will be 1/3 over 4/3, which is just 1/4. Okay, that we do have the first one, and now we will add the second one. The common ratio is again the quantity taken to the power of n, which I see 2 to the n and I see 3 to the n. 2/3, excellent. It's less than 1, it's definitely convergent. Convergent. The first term is defined at n1. 1 minus 1 is 0, 2 to the power of 0, and 3 to the power of 1, 1/3. Actually, it's the same thing, just the common ratio is different. Okay, that means the sum is 1/3, 1 minus 2/3. Actually, 1/3 over 1/3, it's 1. That we have to add 1. The final answer is 5/4. Okay, I have another one. We can delete it. Okay, that we can see that we simply have to split unless we do the job once, but I did twice. Okay. Oh, Kyrie, did I make some typo? I mean some mistake. A is 1/2 for second one. Oh, hang on, are we starting from 1? No, okay, if I will take, what color I can use? If I will take this formula, 2 to the power of n minus 1, 3 to the power of, and then substituting instead of n1, I think I'm getting 1. Okay, that means 2 to the power of 0, 3 to the power of 1. I think it is 1/3. Is that correct? Yeah, I don't know, how did you get 1/2? Yeah, I think yes. Okay, no, it's we can always double check. And of course, that's what we have to do on the test. Okay, that's in geometric series. We can definitely expect. You did multiply by r. Okay, I see. Okay. Okay, now my second question is just asking, I pick 2 infinite series and I'm asking for convergent or divergent, and I also include conditionally or absolutely because it's melted down, melted all of the tests together. Okay, that's what we have. The first one, the series A is defined as a summation from 1 to infinity, -1 to the n, and then we have a quantity n squared plus 2n plus 1 to the power of 2n, and denominator is the quantity n cubed plus 1 to the power of n. And the second one contains factorials. Okay, that means probably we know what test is the best one. Okay, but what do you think? What test shall I use for the first, for the series A? What will be the best test? It's okay, we can try AST because of course you see this, right? Even for both of them. As soon as we see the -1 to the n, it's good. But maybe because A is like, can you imagine taking this formula and like testing if it's decreasing, testing it, yeah, it is positive, and testing for the limit? It will be, I think, quite hard. But what we see we see that the entire formula is taken to the power of n. Can we see n and n? And of course, negative 1 to the n, if I take absolute value of it, it's gone. That means if we have a formula taken to the power of n, what test is good? Is the root test, right? That means let's use the root test, right, for a. Limit as n goes to the infinity, and we have to take the nth root of absolute value. We have to take the nth root of absolute value of this, which means this will be gone, the negative 1 to the n, and I can only put n squared through n plus 1, n cubed plus 1, and what I can do, I can keep the square and I can pull out the n exponent. That means square root of n and the exponent n, the power n, is gone. And now what we can see, we see that we have n to the power of 2 and n to the power of another 2. That means n to the power of 4 and then over n cubed. That means I think, yes, I think this limit is infinity, which will be divergent. Yes, good. And what will be the good test to test the second series, the series B? I think it's the ratio. As soon as we see the factorial, we can use the ratio test. That means let's try ratio test. We will also take the absolute, the limit of the absolute value. A sub n plus 1 over a sub n. Okay, that means the negative 1 to the n will be gone because it's the absolute value. And then, oh, my pen is, and then let's add 1. That means we will have n plus 1 factorial, and it's actually squared. Let me write it this way, n plus 1 factorial. And then 2n plus 1 factorial. And dividing by a sub n means multiplying by reciprocal. N factorial, n factorial. Okay, let's try to simplify. Limit as n goes to the infinity. That means n plus 1 factorial, I can rewrite as a n factorial times n plus 1. Another n factorial times n plus 1. And I can keep 2n factorial. I can copy n factorial, n factorial. Now what we have 2n plus 1, which is 2n plus 2, if we distribute this. Having 2n factorial and 2n plus 2, I have the number 2n plus 2 is 2 more. That means I have to subtract 2. I have to take the number 2 less factorial and then multiply up to 2n plus 2. 2n plus 1, 2n plus 2. It's something like 5 factorial and 7 factorial, right? I will keep 5 and then I can subtract 2 from 7, but still I have to have 6 and 7 to finish my definition. Okay, and now we can nicely see n factorial is gone, 2n factorial, 2n factorial. And now what is the limit? We do have n and n, which is n squared. Right, this is n squared and something else. And in the denominator, we will have 2n times 2n, 4n squared. Excellent. And the rest of them, we're not really interesting because we have to check the highest, the leading function, the highest power. Okay, n squared over 4n squared is 1/4. This is less than 1. This series is absolutely convergent. Okay? Because we know that the ratio test is testing absolute convergence. Okay? Really nice. Okay, I don't know which answer is correct. I believe D, right? You can double check for me. That's what we have to do on the test. All of the options are quite similar. That we have to make sure that we're reading everything carefully and picking the correct answer. Okay, that's me a little bit of root test, a little bit of ratio test. Let's see what else. Okay, now I have the list of 3 infinite series, and the same thing. We have to choose if they are absolutely convergent, conditionally convergent, or divergent. Okay? That means the first one is -1 to the n over 1 plus square root of n. Okay, that means since this one doesn't really include lots of formulas, I think we can take it like it is and apply AST. And that's by alternating series, because we do have -1 to the n. D sub n formula looks like that. Okay, and we can definitely see it's positive, it's decreasing, and the limit is 0. That means it's positive, limit is 0, I can write this way, and is decreasing. Okay, that means this is convergent by AST. But the thing is, we have to check if it's absolutely convergent or eventually conditionally convergent. That means it's definitely convergent, which means this option is not an option for us anymore. Okay, now taking an absolute value, I'm getting just this. Like taking, I can maybe do this, taking absolute value. My AST test didn't include absolute value because of course it will be pointless to use AST. But if I took absolute value, the -1 to the n is gone, it's just 1, and the denominator stays the same. Okay, and we can see we do have the leading function n to the power of 1/2. If I use some type of comparison, maybe limit, maybe direct, I can try even direct. I can definitely get convergent. If the denominator is bigger, the whole fraction is smaller. However, direct comparison is not working because this is definitely divergent because it's n to the power of 1/2. But if I will use the limit comparison, I will get the good conclusion. That means this one will behave exactly the same like the other one. This one is divergent, and you can try later by the limit comparison test. We don't even have to state the test, but we can see direct comparison is not working. Direct comparison test, because if this is divergent, something which is smaller, we don't know, but the limit will work. We will get 1 if I will divide a sub n divided by b sub n. Okay, that means absolute value, it's actually divergent. Again, coming back to the original test, it was convergent. That means the final conclusion is conditionally convergent. Just under the condition, under the alternating condition, we're getting convergence. Okay. That means always the conditional convergent is taking more time. Okay, and now B. What about B? Do you see right away? Because we can see that this limit is 1, right? And having -1 to the n, the limit doesn't exist because it will be like -1, +1, -1, +1. That means, yes, by test for divergence, limit of the entire formula, it's simply undefined. If the limit is different than 0 or if the limit is undefined, we do have divergent right away by test for divergence. I think, yes, Kevin typed this. And this is this is a sub n. Here we can see the limit is not 1. I mean, 1 will be not helpful also, but -1 and +1 alternating, which limit doesn't exist as a one finite number. Okay, and then cosine n pi, I hope we remember this, that cosine n pi behaves exactly the same like -1 to the n. And then denominator, I have n to the power of 3/2 because it's 1 + 1/2. Okay, that means similar situation, AST could be applied. By AST, this is definitely convergent because the formula b sub n, it's only that part, and it's positive, limit 0, it's positive, limit of b sub n is 0, 0, and it's decreasing. That means this is convergent by AST, but when I apply the absolute value, testing for absolute convergence, you can nicely see that this will be 1 and this will stay the same. And by the p-series test or the integral test, p-value is greater than 1, it's definitely convergent. That means absolute value is convergent, it's absolutely convergent. Okay, nice selection of infinite series. Okay, and now I believe that means the previous stuff, the stuff that I just covered was from chapter 11, but was theoretically the old stuff before midterm 2. Now this screen will open the discussion for the new stuff, which means the power series, Taylor series, Maclaurin series. And that means that's what the new stuff starts. Okay, that means this is the screen with the formulas that we have to remember, okay? And we remember the geometric, the power series representation of the rational function based on the geometric property. That means 1 over 1 minus x, it's just the power function x to the power of n, which of course the power function with the infinitely many terms, okay? And the degree of n. Okay, we also did e to the x, that's this formula. We can see x to the n over n factorial. Sine of x, x to the power of odd number over odd number factorial, 2n plus 1, 2n plus 1. Cosine has even number, 2n, 2n factorial. And tangent, inverse tangent, it's similar to sine, when you see this, except we don't have the factorial in the denominator, just 2n plus 1. And all of this trig function are alternating ones, negative 1 to the n. That means I will really recommend to recognize, yes, not just purely memorize, just kind of memorize, but through the practicing. And now that's how we can ask you, where are my questions? Okay, that's the question that we can state on the test, testing if you know these formulas. That will find the sum of the following. Okay, the first one, do you recognize the formula? What's the first one represents? What's the power series representation of what function? Can you see the denominator? 2n plus 1 only, and the number is taken to the power of 2n plus 1. That means it's inverse tangent, and this is the number. Yeah, because instead of x, we have square root of 3. And do you possibly know tangent for what angle is square root of 3? 60 degrees. Okay. Okay. Yes, pi over 3. Thank you. Thank you, Kevin. Okay. Now, second one. The first one, the second. Okay. What about the second? Do you recognize the formula? I think the easiest way is to look at the denominator, 2n factorial, or it's even number. It's cosine, right? But let me do one more thing, because we do have negative 1 to the n. It's nice to see 2n factorial, and also pi over 3 to the power of 2n. Can you see what I did? Because this is 3 to the power of 2n in the denominator and pi to the power of 2n. That means I can combine them together instead of like dropping the 3 down. I'm combining them together because now I really match my formula. I have 2n factorial and the number to the 2n. And this is definitely cosine of that value. What's the cosine of 60? Cosine of pi over 3? Oh, unit circle? I know that you know. It's a half. Yeah, thank you. Thank you, Garrett. It's 1/2. Okay, and then do you recognize the third formula? What's power series representation is this for what function? Now it's sine, thank you. And it's just this number. This one is square root of 3/2. Yeah, it's opposite to cosine. And that's what you can see based on denominator. Okay, what about number 4? Number 4 is e, but we have to be really careful because the e to the x, it's not alternating. That means -1 to the n, it's not really, how can I say, it's not really the part of the main formula. We only have n factorial in the denominator and quantity to the power of n. And the quantity in my case is -1 and 2, -2. And now I know that is e to the power of that number. Okay, that means make sure that this one was fine, this one is okay, the alternating parts, but not the e to the x. I can actually come back. Yes, can you see this? We do not have -1 to the n like we have here. Okay, good. That means that's the way that we may ask. Okay? Be careful. Nice and easy points. Okay, next one. Okay, and then I think we do have this type of questions. We have to find the radius of convergence. We have to find the interval of convergence. Okay? Let's just do this one. The power series, -1 to the n, 5 to the n, n cubed times x plus 2 to the n over n factorial. Okay. And we remember we have to just use the ratio test, and the ratio test will tell me a lot, okay, to find the radius. I mean, the ratio test is helping me with an interval. If I have interval, I can nicely find the radius because the radius is just the distance from the center to the edge, to the endpoints of the interval. Okay, before I start computing, looking at this formula, do you think you can tell me what is the center? What's the center of this power series? Like, do you remember whatever number we subtracting from x? That's in what number I'm subtracting from x? If this will be just x to the n, it's 0. But I think looks like I'm subtracting -2. Subtracting -2 means adding 2. That means based on these numbers, I can figure out the center. Okay, that means let's apply a ratio. Limit as n goes to the infinity, a sub n plus 1 over a sub n. It's absolute value. That means I will again ignore this. Okay, -1 to the n. Let's see. What we have? 5 to the n times 5. N plus 1 cube x plus 2 to the power of n and x plus 2 to the power of 1. And this is n plus 1 factorial. I have to keep absolute value because I have x. And then multiplying by reciprocal. 5 to the n cube, x plus 2 to the power of n. Can I simplify at least something? I can cancel out this and I can cancel this. Actually, n plus 1 factorial is n factorial times n plus 1, which means I can cancel this. I don't have to rewrite over and over again. 5 n plus 1 cube and then just n cube and x plus 2. Yes? Remember, we have to kind of like split the n's and the x's. For n, I don't have to keep absolute value because it's always positive. Okay, that means what is this limit? Yes, we can see we do have n cubed and n cubed. However, on the top, we have 5. That means the limit is 5, thank you. 5, the final answer is 5 times x plus 2. Or maybe, oh, no, something is missing. Oh, something is missing. Can you see what I did with n plus 1 factorial? I did rewrite as a n factorial times n plus 1. That means in my denominator, I do have n cubed I also have n plus 1. Yes, we have to be really careful. Oh, good that that's the n plus 1. That's me now. I think we have n cubed. Yes, now it's 0. Thank you, Kevin, for walking through with me. N cubed and n to the power of 4. If the denominator has a greater power, always 0. Okay, that means 0 times anything is just 0. And based on the ratio test, I mean, we're not looking for the interval, but if this will be an interval, we will say, because 0 is always less than 1, always. And that means if 0 is always less than 1, doesn't really matter what value of x I substitute, I will always have convergence, always. That means an interval of convergence, which is not really the question, but I'm just adding as a learning thing, because all of the numbers will work. We will always get 0. 0 by ratio test is giving me convergence. That means if all of the number works, what is the radius of convergence? Oh, it's 0? No, let's think about this. Think about this interval. It's infinity. Thank you, guys. It's simply infinity. That means now we have to be careful. If you're getting 0 by the ratio test, the radius of convergence is infinity. Okay? Isn't that the center? No, the center is actually -2. I know, looks maybe a little bit weird, but if I would like to go to the edge, I have actually infinity. Doesn't matter that it's shifted to units, doesn't matter that it's like not 0, but going to one direction to negative infinity and positive infinity, it's still big number, infinity. Yeah, that's mean. So the radius is 0 when you, exactly, Kevin, yes, that's what I was gonna say. It's kind of opposite. When you, let me repeat this, and it's important, okay? Whoever is attending now, or if you're watching this later, if you getting 0 by the ratio test, means everything works. Radius is infinity. And I will just repeat what Kevin said. If you will get infinity, this means no convergence. That means radius is 0. Right? It's kind of opposite. Also, be careful. Okay, good. Okay, next one. Okay, an interval of convergence. That means interval of convergence, we have to do the same thing, and we will work out the interval. I was confused between 0 and infinity. But Kevin, you okay now, right? Okay, good. It's kind of opposite. Okay, it's up. Please remember, it's opposite. Can you see the answer? And I mean, can you see the output of the ratio test and you see the final answer? Yeah, okay, good. Okay, let's do the ratio test for this one. Ratio test. And we do have 1 over n and 2 to the n and x plus 2 again to the power of n. That's mean ratio test is the ratio of a sub n plus 1 over a sub n. Limit. Okay, we do have x plus 2 to the power of n and x plus 2 to the power of 1 because it's plus 1. And then n plus 1 and 2 to the power of n and plus 1, which is 2 to the power of 1. And we can multiply by reciprocal. And we still have to keep absolute value. Of course, I'm ignoring this because absolute value of this is 1. Let's see. Oh, I can simplify this and this, this and this. Okay, and let's put n's. N and 2n plus 1 and absolute value for x plus 2. That means absolute value for x quantity, not absolute value for n. Okay, what is the limit with respect to n? N over 2n, it's 1/2, thank you. That means the final limit is 1/2 times x plus 2. for the power series to be convergent and by the ratio test, this has to be less than 1. That means let's solve this inequality. This has to be less than 1. Let's multiply by 2. And now the quantity between must be between 2 and negative 2. Yeah, I think the radius is 2, because we can see this, the radius is 2. Okay, let's subtract 2, 0, and negative 4. Okay, that means an interval is between negative 4 and 0. However, we still have to test the endpoints. Because can you see maybe this one, or maybe this one. And we still don't know. The endpoints are important, but at least we have a main limits. Negative from negative 4 to 0, and the center, it is negative 2. Can you see again? The center is the number that we're subtracting from x. That means the center works. Okay, let's see if we can accept 0 and negative 4. Then will be answer A, or maybe one of them is included, or maybe both of them, like answer C. Okay, we have to take negative 4 and substitute instead of x. That means infinite series will be defined as a negative 1 to the n plus 1. I can do n, 2 to the n. And if we will put negative 4 plus 2 to the power of n, I will have negative 2 to the power of n. I don't wanna, which this will be, this will give me negative 2, of course, we see this, which is negative 1 and 2, if I separate this. And then I don't wanna mess up my solutions. 1/2. Okay, that means what we have, we can simplify this. And now I have negative 1 to the n plus 1 and negative 1 to the n, which this is giving me 2n plus 1. That's me. If I have n plus 1 and n, I can add the n's because I have the same base. Negative 1 to the 2n plus 1, it's always negative. That means I actually have this. Right? Because we can see negative 1 to the n plus 1 and to another n, we're adding the exponents. 2n plus 1 is odd number. Negative 1 to the odd number is always negative, which I can place here. Okay, that means I only end up, it's not an alternating one. It's not alternating one. That means I did end up with 1 over n, harmonic one, with all of the negative terms. This is definitely divergent. Okay, and then if I substitute 2, that means if it's divergent, that's not an option. Maybe this one, maybe this one. Now, if x is 0, what happened? I believe we have alternating one. Because we will have negative 1 to the n plus 1. If I substitute 0, I have just 2 to the n. And this one is the alternating one. It's harmonic alternating. That means it is convergent. Yes, thank you. Convergent. Which means convergent means that I can add 0 because I'm looking for interval of convergence. I'm not gonna add negative 4. That means now we can remove everything, and this is the final answer. That means make sure that you test the endpoints. Okay? Not only because we can see it's still few options to choose. Okay, radius interval. Good, good. We're doing well. What else I have? Okay, express a function as a power series. And the function we can see is relatively easy. Yeah, nothing complicated, matches nicely to the a nice rational function. Okay? That we can move the numbers a little bit and check which one works. Because what I will use this tool, 1 over 1 minus x the power series representation. Actually, we're starting from 0. It's just x to the n. And x is between -1 and 1. Okay. Oh, no. What I'm doing, I'm making mess. Okay, I wanted to make box. Okay, that means let's see our function. On the top, I need 1. That means I will rewrite like that. Now, I can even rewrite maybe like that. Now, I don't really need that 3. I will factor out 3. Okay, we can see what I'm doing. I did factor out 3. 3 times 1 is 3. 3 times x over 3 is still x. But I have this extra part. And now, am I taking lots of space? I have 1, and I need minus, which means I will subtract a negative number. That means now I am matching perfectly to that formula. It's 1 over 1 minus, and that's my quantity. Negative x over 3 will be placed here. Let's get the power series representation. Copy this and power series negative x over 3 to the power of n. Done. And of course, this works if and only if this expression it's less than 1. The same thing. Yes, this is the expression. We can ignore a negative number and we can multiply by 3. That means radius is 3. Just in case if we would like to match this. Okay, but one more thing, we have to make this formula looks a little bit nicer. That's what we will do. I will rewrite. We have -1, we have x, and we have 3. Each quantity is taken to the power of n. -1 to the n, x to the n, and 3 to the n. And we also have a quantity in front, x to the power of 1 and 3 to the power of 1, plus 1, plus 1, because I can add the exponents, and this will be moved. Okay, that means that's my final answer. -1 to the n, x to the n plus 1, over 3 to the n plus 1. And this also match. Okay? Yeah, that means make sure that you know how to get the power series representation for the basic function. Okay? Like this one. Okay, good. Any question, of course, I can take it. But if you, and I will repeat again, if you can solve all of these problems, you understand the concept, you should be good for almost 50% problems on the test. Okay, now what we have? We have another function, but it's defined as an integral, and it's x times cosine of x cubed dx. X cubed, okay, because it was covered. That's mean what we have to do. First of all, the function inside, I have to rewrite as a sigma, as a power series representation, and then integrate. And we know the integration is relatively easy. That's what we will have. We will have x, and we remember cosine for Maclaurin, it's starting from 0, -1 to the n, quantity to the power of 2n over 2n factorial dx. And this quantity is actually x cubed in this case. That means let's rewrite. Starting from 0, -1 to the n, x to the power of 3 times 2n, it's 6n over 2n factorial. And since we have to integrate everything, this is x to the power of 1. That means I will add 1 and I will cancel this one. Okay, that means now we remember, integration means that we only focus on the x expression. Everything else is a constant. That means we will start with the constant of integration, and to integrate this, I will copy everything, -1 to the n, 2n factorial, okay? And now I will only integrate x to the power of 6n plus 1, which will be integral means that we adding extra coefficient, extra 1 in the exponent. 6n plus 2 over 6n plus 2. Yeah, we remember like integral of x cubed, it's x to the power of 4 over 4. Integral of x to the power of 5, x to the power of 6 over 6. That means I did add a number. And shall I simplify? Let's see the options. No, I don't have to because I see 6 and 2 I was thinking to factor out. But I think we don't have to. That's it. Hang on, I don't like that. Do you see the answer? I will just cross it like that. The answer, I think, is it is a 6n plus 2, yes? Mm-hmm. And I also type for you in the options, the expanded form, but that's fine. Okay, that means that's how we can integrate only the x part. Do not any constant, any n, only x. Okay, we good with this one. Oh, we'll skip this one. I mean, you can check this question, but this is the same question, different function. Okay, that means now we have to find a Taylor polynomial, okay, for the given function, ln of x plus 1, centered at 1. Third degree polynomial. Let me remember, the third degree polynomial was value of the function at 1, value of the first derivative, 1 factorial, x minus 1 to the power of 1, value of the second derivative at 1, 2 factorial, squared, and 1 more. Third derivative at 1, 3 factorial, x minus 1 cube. That's third. 1, 2, 3. Okay, that we have to just find the first derivative, the nth derivative, and then the nth derivative at 1. 0 is just the function, 1, 2, 3. Okay, 0 is just the function, ln of x plus 1. 1 means the first derivative. Derivative of ln of x plus 1, it's just 1 over x plus 1. Second derivative is negative 1 over x plus 1 squared. And the third derivative will be positive 2 x plus 1 cube. Substituting 1, we have ln of 2. 1/2, negative 1/4, 2 cube is 8, positive 1/4. Okay, that means that's the values that I will use it. Okay, let's see. The third degree polynomial is, this value is ln of 2. Now the first derivative is 1/2. The second derivative is actually negative 1/4, but we still have 2 factorial. Please remember about this. And the third one is also 1/4, but we have 3 factorial. Okay, that means that's the final answer. Do you think you can tell me which option is correct? We have a coefficient 1/2, 1/8, 6 times 4, 24. Oh, hang on, this is positive. This is negative. That's mean Kevin is saying E. What about A? Oh, no, A is wrong here. Yes, I think it's E. Yeah, that means please remember, I can tell you, I will use different color. This is the common mistake to forget about the factorials. They were part of the formula. That means the meanest option is, I think D is the meanest option because it's 1/2, negative 1/4, positive 1/4. Can you see? 1/2, negative 1/4, positive 1/4. Yeah, that's wrong because we're missing the factorial. Okay. That's when you will do this, and then what you will have, yeah, I suppose to have, we will ask you for the Taylor's inequality. That means use the work from the problem above. And because I had the number, but I removed it because I didn't keep the order. That means use the work from the problem above and Taylor's inequality to estimate the accuracy of the approximation of the function by the third degree polynomial, and a function is the same function, centered at 1, but we only want to do the approximation using the interval from 1/2 to 3/2. That means Taylor's inequality, okay, we remember, using the third degree polynomial, it's 3. We can approximate, it's always this error, this estimation is less than the next term. That means this is m, this will be 4 factorial, and this will be x minus a, which actually is the center, to the power of 4. That we can see is kind of like the next term. Can I switch? Can you see I had 3 factorial 3, and then we know that in the Taylor's inequality we have to look at the next term. That means m is the maximum value of the next derivative, which is the 4th derivative. Okay? I will use this information and find the 4th derivative, which will be -6 x plus 1 to the power of 4. Okay, and we don't need this value because I have to maximize. That means it's -6 x plus 1. Hang on, it's plus 1, yes, to the power of 4. Of course, we're maximizing, that means always positive. And now we have to maximize this, the maximum value of the 4th derivative on the given interval from 1/2 to 3/2. And please be careful now, because I think that was also one of the questions that I got from the homework assignment. In order to maximize a fraction with x in the denominator, we have to minimize denominator. Okay? Because we remember, if the denominator is big, the whole fraction is small. Or if the denominator is smaller, then the fraction is bigger. That's mean, in order to maximize, I have to substitute 1/2 because I have to pick a number from the interval. But please be careful, if x is placed for some reason on the top, then pick the maximum, of course. Okay, that means, let's see, 1/2 plus 1. Am I right? It is plus 1. Okay, just, that means we will have 3/2 because I will substitute 1/2 to the power of 4. Okay, let's just keep it like that because I don't wanna, or maybe I can simplify 3 to the power of 4 and I can flip 2 to the power of 4. Okay, let's just leave it like that. Okay, that's me now. Let's see. My m value is 6, 2 to the power of 4, 3 to the power of 4, and 4 factorial, which is 24. And now we also have to put a quantity for x. But that for x doesn't matter. You can put 1/2 or 3/2. Because we will always maximize the value, because we also has to maximize this. But if you will put 1/2, you get -1/2, which absolute value is giving me half. 3/2 minus 1 is also 1/2. That means this is theoretically the radius. Okay, if you would like to think this way, or you can put this number. Because the radius of, I mean, we can see the half of this interval, it's actually half. That means this will be 1/2 to the power of 4. Okay, that's mean what we have. I don't know if I see the correct answer. I think what we can do, we can simplify 6 and 24. This will be 4. And we have actually 2 to the power of 4, 3 to the power of 4, 4, and this is 2 to the power of 4. That means both of them are gone. My answer is 3 to the power of 4 is 81. because it's 3 times 3, 9, 9 times 9, 81. Okay, 81 times 4. Can we do it without a calculator? Who can tell me what is 81 times 4? 324? Okay, that's my estimation, my accuracy is, it's less than 1 over 324. Quite good, quite small number, good, small mistake. Okay, and we can see just the 4, the 3rd degree polynomial. Okay, but please make sure that you know how to deal with the Taylor's inequality. Okay, what else? Okay, that was everything for chapter 11. That means now, since we did have a really nice session last week for chapter 10, let's just go through really quickly with some important questions. Chapter 10 was the parametric curves and the polar curves. Okay, this is the parametric. We do have 2 equations for x and for y, depends on t, and we have to find the slope of the tangent, which means we have to find out the derivative, y prime over x prime. And we remember just the derivative of the parametric curve. Y is defined as a tangent. Derivative of tangent is secant square of t. Derivative of secant square minus 1, derivative of secant square will be 2 times secant times derivative of secant, which is secant times tangent. Minus 1 is giving me 0. But please remember, do not do any quotient rule. This is just the derivative, y prime, x prime. I see what I see. I see Kyrie is, Kyrie, what are you saying? You're saying that this is tangent. I can simplify. Okay. Y prime, hang on, this is actually, now I can simplify. That means I do have 1 over 2 tangent of t. How did you get square, tangent square? Or maybe I am wrong. No. Okay, the derivative of y, derivative of tangent of t, secant square of t, of course you can correct me, and derivative of secant square will be 2 times secant times derivative of secant. Yeah, do you think this is correct? I know that everybody is watching, and I like when you're correcting me, because then you're really paying attention. I know she did secant. Okay, just it is correct. It's just the Pythagorean identity. Of course, I didn't. Okay, I didn't think. I really was focusing on the derivative. Yes, this is correct. I can write this down because we do have tangent square of t plus 1. It's secant square of t. That means secant square of t minus 1. Of course, is tangent square. I'm really sorry. I thought that yes, that means you're correct. Okay, but I used this one. We can still rewrite and differentiate tangent square, but yeah, it's the same thing. Okay, I didn't even think about the identity. Okay, but now we have to substitute negative pi over 4. That means the slope, it's the derivative, but we have to put tangent at negative pi over 4. That means it's gonna be negative, and tangent at 45, it's, oh, no, not square root of 2 over 2. Do you think it's 1? Tangent at 45? Or, just to be more consistent, negative 1, because it's negative 45. And that's the answer is this one. Yeah, thank you. Okay, that means make sure that we know derivative of the parametric curves. And some identities, that's it. This is still helpful for some integration. Yes, we remember from yesterday's session and from chapter 7. Okay, that means that's still, for some reason I didn't pay attention for the identity. Okay, that means you're ready, guys. Good, good. Okay, now another parametric equation, but now we have to just convert. Converting means we have to eliminate the parameter t and get just the x and y. Yes, Kevin, you're right. Yes, she has really good memorization. Ready, yes. Okay, that's what we have. We do have x formula defined as a e to the t plus 1, and y formula is defined as a e to the t squared. That means normally what I will do, I will solve for t, one equation, and substitute to the other one. But in this case, I will just solve for e to the t. And you see, e to the t is x minus 1, then e to the t is x minus 1, and then y, it's x minus 1 squared. That's it. That means this is our equation. And sometimes you probably saw a question in the week 11. We may ask you what type of curve it is. If it's x squared, of course, it's parabola. Okay? And we do have some limitation, but x is here. X is greater than 0 because e to the t is never negative. That means x will be always greater than 0. And with the t positive, that means just a few limitations. But don't worry for this. Make sure that you know the main formula. Okay, that means that's the way to eliminate the parameter. Okay. Polar curves. That means we also have to polar curves and the polar equation were a little bit different. We remember like r and theta instead of x and y. That means what we have to do in this one, we have to convert x and y's, we have to eliminate, and we have to see r and theta. That means what you will need, 4 equations. You remember this one. That means 4 equations that are making a connection between x, y, and r theta. That means this one is the first one. Tangent theta is y over x, and then x is defined as a r cosine, and y is defined as a r sine theta. And what if that will be me taking a test, if I will see this question, I will put down all of these equations because it's so, even if you know them, it's so nice to look at them. Yeah, because then they will give you some ideas how you can rewrite, how can you twist them. Okay, that's what I will do first of all. I will say that x is r cosine and y is r sine theta. This one is, of course, x squared plus y squared is r squared. Okay, r squared, cosine squared, r squared, sine squared, and this is just r. We can factor out r squared, and I can even divide by r. That means we will have r equals to 1. And who can tell me what is this formula now? Oh, I would like to nicely, since we're talking about some, it's the cosine to theta. Cosine to theta. And I think that's it. R cosine to theta is equal to 1. Okay, that means that's the way to, but I can tell you it's really easy if you have these, if you're looking at them. Okay, let's see the other way. I think I also, okay, now I'm giving you the polar and I want you to eliminate r and theta and put x and y. That means, let's do the same. R squared. Okay, first of all, I see sine 2 theta. I will use the formula 2 sine theta, cosine theta. You remember double angle. Okay, what I will do, I will keep this. I can possibly divide by 2. Actually, this will be 2. And sine theta, you see I didn't put them down, but it's really nice to have them. That means sine theta is y over r. Okay, y over r. X is x over r. And I can cancel out this because it's r squared in the denominator. That means x times y is 2. Excellent. And I can solve for y, 2 over x. Really good. I did eliminate angle theta and r radius. And this is hyperbola, 2 over x. Okay, that means, let me just quickly make a comment that's important. And without this, you can miss 2 or 3 problems. I know you will not. Okay, oh, you will check later. I will keep this one for you. Okay, and then we remember we have to know the main curves, the polar curves, which will be the circle, cardioid, the cardioid with the loop, which we call limaçon, and the flowers, but just the basic flowers, the 4 cosine to theta and sine to theta. Okay, that's what we see now. Of course, we have to know the curves. Actually, okay, maybe we can recognize, let's start with this question, and then we can do a few areas, and that's it. Which of the following represents the polar curve r equals to 1 plus 2 cosine theta? What do you think? Can you tell me which option is definitely not the option? Which one you will eliminate right away? Okay. You can definitely see that this is more, which means must be the heart, the cardioid with the loop. That means it's not a cardioid and it's not a circle. And somebody, Kyrie, yes, we have the answer B. And probably it is, because we remember as soon as we have wider, more values, I think this is 3 because 2 plus 1. On the x-axis is the cosine. That means this is also not an option. This will be answer. This will be the answer B. Okay? But you can definitely, because I don't want to go really again, you can check my session from last week. Yeah, you remember the first half an hour was the nice summary of all of the shapes. Okay, cool. Now I have 2 problems, 2 areas. What integral represents the area that lies inside both curves? R equals to 1 minus cosine theta and R equals to 1 plus cosine theta. That means let's draw this first. Both of them are just that's the shape, right? Like it's just the heart. But I don't know if this is this way, or maybe this way, or maybe this way. Yeah? Probably wider on the x-axis. That means this way or this way. But let's check. Let's check the first one. Cosine at 0 is 1. 1 minus 1 is 0. That means I will start with 0. Cosine at 90, that's my angles. Okay. Cosine at 90 is 0. 1 minus 0 is 1. That means I will go this way. And at pi is -1. Subtracting -1 is 2. And then again 1. And then, oh, terrible. But we know, okay, that means the first one will be this one, and this one will be opposite. That means, let me draw it. I know that you know the values. I will draw a little bit nicer, if I can. Oh, okay, that means this is the first one, and the second one will be opposite. Oh. Oh, they are the same size. Okay, 2, and also 2, 1, and 1. Okay, that we have to find the area which lies inside both. Okay, that means I think is this part. Okay, and do you think we can use the symmetry? We kind of have like a, oh, they all look the same. I know that maybe my picture, it's terrible, but all of these sides, these halves are the same. That means I will only focus on one part, okay, and I will multiply by 4. Now we will multiply by 4. That means, remember, do you remember our nice 2 multiplying by 2 from the last week? Now we have 4. But let's see. That means the area will be defined as a 1/2. Okay, let me write the formula, r squared d theta. Because normally when we have 2 curves involved, we will subtract. But you can see that the green part, it's only bounded by 1 curve. That means in this case, I can use just 1 curve to define the area of this. That means we can see the limits of integration will be from 0 degree to 90, because it's from 0 to 90. That means this will be 0 to 90. Let me do it here, from 0 to 90. Okay? And we do have 1/2. And if I would like to cover all of them, I will multiply by 4, because I do have 4 of these quarters, like 4 quarters, I can say. And now r squared d theta. And what do you think? This one, the red one? What? Okay, the red one is the first one. 1 minus, okay, Garrett, did you say the answer B? 1 minus, oh no, hang on. That maybe was from the previous one. 1 minus cosine theta. That you can see the red part, this green part is bounded by the red curve, which is this one. 1 minus cosine theta, that's r squared d theta. But who can tell me the answer? Is the answer really B? It's actually D. Because we can see 1/2 times 4. Right? That means not 4, because 4, we only the 4, we forgot the half. 1/2 times, that means the coefficient in front is 2. And please remember, make sure that you like pay attention to this coefficient. Normally we will multiply by 2 if we're using this. Okay, we remember this Bluetooth from last week, and then times half, which will be gone completely. But in this case, we multiply by 4. Oh, of course. Thank you. Who was telling me B? Well, it is Natasha. You're right. It is A. Oh no. Okay. No. I don't wanna give you this wrong. Yes, it's minus. It's definitely, if this will be from 0 to 90, 1, that means this will be actually, can you see, I don't want to mess up, but maybe from 0 to 90 will be just, I think will be that part. Yeah, if we will use the answer D, because then it's bounded by the blue curve, 1 plus cosine. Okay? But we don't, no, I will remove this. We don't want this. Yes, thank you. Who correct? Natasha, thank you. It is the answer A. It is A. Let me use the green color because matches to, I mean, now to every, now, okay, it is just A. I don't want to, yes. But okay, that means pay attention to the function, of course, and pay attention to the coefficient. Okay, let's do one more. The area is 4. Kyle is asking, oh, I don't know because we have to evaluate. But we will not evaluate for this type of question. Maybe if did you evaluate this integral? We don't have to. I think on the homework assignments I asked you to evaluate, but for this one I really would like to see the integral. That you will just pick an integral expression. You can simply, I mean, you can simplify this. I mean, you can simplify and integrate, but we can leave it like that. Yeah, maybe if you did, maybe for, I don't know. It's definitely this integral, and I don't know what is equal to. Okay, and then we have one more, the same thing. We have to find the area, just the integral expression that represents the area of the region which lies inside a circle 3 cosine theta, and outside the cardioid. Oh, this one is the same thing. That means what we will have. 1 plus cosine we just did. That means 1 plus cosine was the blue one. Can you see the blue one? That means we will do. Okay, not bad. This will be the second one. And this is actually 2. 1, 1, and 0. Now, this one, the first one, it's cosine, which is the circle in the first and the fourth quadrant with the diameter 3. Oh, okay, not bad. Right? That's mean that, and that's the 0 degree. 90, 180. Okay. And let me use inside the red and out, no. Inside the blue and outside the red. I think it's this one. You can double check, but I believe it's this one. That means we will need that angle and we will need, oh, this angle. It's symmetric from A to B. Or we can use a symmetry from 0 to the angle B and multiply by 2, which you can probably see the coefficient in front of the each integral, it's gone because it was multiplied by 1/2 times 2. Okay, how can we find the angle B? We have to find the points of intersection. 1 plus, oh, I can start with the first one. The first one must be the same like the second one. 3 cosine theta equals to 1 plus cosine theta. Cosine theta, it's 1/2. Cosine for 60 degrees, it's 1/2. That means this will be negative. Okay, that means the area will be equal to, okay, now we have to subtract. Okay? That means what we will do. Integral, let's say from A to B, 1/2 r theta, r squared minus 1/2 r squared. And we remember we have to subtract the longer one. That means the longer is this one minus the shorter one. Yes? That means this will be the blue one, which is actually the first one. Okay. 3 cosine theta, and this will be the second one, the red one. Can I put somewhere? 1 plus cosine theta, and 1/2. That means now it's 1/2 r squared minus r squared d theta. And the first one is 3 cosine theta, 1 plus cosine theta. Okay, and the limits of integration, we can actually say from 0, okay, we will say from 0 to pi over 3. But now we're just looking at half of the region, which means we will multiply by 2. Bluetooth, you remember that. Okay, I believe that's everything. That means 1/2 times 2 is gone. From 0 to pi over 3, and the circle minus the cardioid. The longer distance from the pole minus the shorter one. Okay, and who can tell me which option shall I pick? Which one is the good one? Who can help me? It is D. What is the problem with E? Oh yeah, E has the wrong limit. Yes, thank you. Thank you for iPhone. Let's double check. 9 cosine square and this one. And we can see, I just squared 3 and cosine, but this one will stay like it is. Okay, that means this one has the wrong limit, I see. Okay, that means that's how you can deal with the areas. Okay, that means I really believe I went through the important question, and one more time, if you're gonna be confident with these questions, 40% of the test, you will ace it. Okay, and of course, you did have the review session yesterday. That means you should definitely ace the entire test. We can still take some questions. That means if you can put the questions on the discussion board today or tomorrow, I can still answer, because you will still have a short session with Han tomorrow. Okay? That means you can still, even if the test is open, we will probably not ask the direct question. I mean, we can't ask the question from the test if somebody took the test, of course, earlier tomorrow, but you can definitely ask like a review question. Okay, tomorrow is still a good time. And then one more thing, I will update all of the grades on Canvas gradebook probably Saturday, and I will still wait for your final exam. Okay, thank you for today.